Hello guys, my name is Hossain. Welcome back to my data structure series. Today I am doing the part 3 of a Sparse Table data structure. In the previous video, we have seen that how can we answer any range query by using a Sparse Table, but that needs order login time per each query. But the problem arises when the number of queries at most 10 to the power 8. So then it if we do this login time per each query, then we will get daily, right? So what we can do then? So let's see. So suppose this is the array we're given, and size of the array is same, which is small, 10 to the power 5. So we can do this pre-processing by using a sparse table in the same way of the previous video. We have seen that, but the number of queries can be at most 10 to the power 8. So we can't do order login time per each query that we have done in the previous video, right? So we have to do some optimization then. So what are the optimizations we can do? So in the previous video we have seen that if we have to answer some range queries, suppose the from range L equals 3 to R equals 8. Okay, this is 3, 4, 5, 6, 7, 8. This is 8. Okay, 3 to 8. We have to answer what is the maximum element of this range, right? 3 to 8. So if we do it in the same way that we have seen in the previous video, then what we will do? We will take the maximum power of this range, this length, which is 8 minus 3 plus 1, which is 6. We will take the maximum power of base 2 of this length. Then we will take the maximum element of this length from this position. Then we will jump that length. Then from that position, we will again take the maximum power of base 2 length. Then again we will jump that length. In this way we will do again and again. It needs login time, right? But we can do better than it. What we can do, we can firstly we will take the length, we will calculate the length, which is 6. Then we will take the maximum power of base 2, which is max length is 6. Then the maximum power of base 2 to make length less than equal 6 is 2 to the power 2 is 4, right? Then what we will do, from this position we will take the maximum element of this length, which is length 4. We will take the maximum element of this length, which is 25, you can see. Then what we will do, instead of jumping this length, we will jump from the right position. We will jump backward similar to this length. We will jump the this amount of length from backward from our position. Okay, then the position will be 8 minus 4, right, which will be 4. So this is 4. Then what we will do, we will increment our position by 1. So then the next position will be this. Then from this position we will again take the maximum element of size 4. Okay, then the maximum element will be in this range. So now we are covering the whole range, right? So then the maximum element of this range is 25, and the maximum element of this range is also 25. So then the maximum of this range and this range will be 25. So in this way we can answer any query. So we are doing only two operations, right? We are only doing two operations per each query. So this takes constant time operation. We don't need login time operations. So what are the operations we can do in the similar way? Depends on a property of this operation. What is the property? The property is idempotent. The idempotent means a dot a should be 0. Here dot means any kind of operation. So if a dot a gives a, then this will be the idempotent operation. If any operations have idempotent and this property, we can apply this similar technique. Okay, in the maximum operation we have idempotent property, right? Because maximum of a and a equals a, right? So we can do maximum in this way. We can also do minimum, right? Minimum of A and A is equals A, right? So we can do minimum in this way. We can also do GCD in this way, because GCD of two similar numbers, which is GCD of A and A, gives A, right? So we can do also GCD in this way. So let's see how can we getting the correct answer in this way. How can we getting the exact answer? So suppose this is the length of the array we are given. I am not showing the elements of the array. I am just showing the array length. Suppose we have to answer the query in this range. Okay, in this range, which is 2, 4, 6 length. Okay. So first of all, what we will do, we will take the maximum element of length 4 from this position, right? So the range will be this, because to make length less than equal 6, the maximum power will be 2 to the power 2 is 4, right? Then from position R we will jump backward by length 4, right? Then the position will be 1 2 3 4, this position. Then we will increment our position by 1, then the position will be this. Then from this position we will again take the maximum element of length 4, right? So this range, then we will take the maximum element of these two range, right? So suppose in this range maximum element is A, and in this range maximum element is B, and in this range maximum element is C. So actually what we have to do, we have to do A, maximum B, and maximum C, right? We have to do maximum of A, B, and C. It will be our answer, right? So what we are doing, we are taking the maximum of these range. What is actually A maximum B, right? So we are doing A dot B. Actually we are doing A dot B, right? Then we are taking these range maximum, which is actually B, maximum of B and C. So we are doing B dot C, right? We are doing B dot C. First we are doing A dot B, and then we are doing B dot C. Then what we are doing, we are combining these two range. That is, we are taking the maximum of these two range. So we are doing this uh, two range dot operation, so which is maximum. We are taking this maximum and this maximum, then we are combining these two maximum. So we are doing this, then we can rewrite this equation by in this way. Actually we can rewrite it, so it is B dot B. We can rewrite it in this way, right? This is the similar expression. So then what we can write, we can write B dot B is B, right? We can remove on B, because maximum of B and B is B. So then we are actually getting the A dot B dot C, which is our expected result, right? In this way we are getting the exact correct result. Okay, so let's see the implementation now. So this was the code we have seen in the previous video. We have initialized the log array, we have built the sparse table, and we have answered the query in log and time. Now we will make another function of query2, which will return answer by constant time operation. Okay, query2, suppose, sorry, this will be this query2. Okay, we will take L and R. Then we will take the maximum power. We will take the maximum power, which will be some length. We have to calculate this length, which is R minus L plus N, minus L plus 1. This length. Then what we will do, we will take the maximum. Maximum will be max of, from this position, which is L. We will take the maximum of these max power length to the power max power length, right? Then we will change our position. What we will do, we will jump backward of this to the power max power length from R, this max power length, which is on left shift max power, right, to the power max power length. Then we will add 1 to our position. Then from this position we will take the maximum element of to the power max power length, right? Then we will return our maximum. Okay, let's this will change to be query 2, and then let's check if this is correct or not. Oh, some error, sorry. Oh, this should be equal. Oh, sorry. Um, oh, sorry. This should be max equals log of length. Okay, I have made the mistake again and again. Okay, now add this semicolon. Many mistakes I have made. Okay, now it is correct. Let's take an array of length 8. Let's take this 1, 3. Okay, 8 length array. Let's take these mini queries. Let's check maximum of all the lengths. Okay, this is 45, you can see. Then maximum of range 1 to 3, which is 5, correct. Then maximum of range from suppose 3 to 5, which is 21, correct. Then let's take the maximum of 6 to 8, which is 45, correct. Let's take the maximum of 6 to 6, which is 35, correct, right? So all seems to be fine, I think. So this was all for today. Till the next video drops, keep practicing, and thank you for watching.